Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. And a very warm good morning to all of you, those who are physically present here and those who are online. How many would be online? That's all?
So there are 10 participants.
10. And mashallah, here about 60.
Yes, sir.
Great. I have two lectures to present to you. I won't say lecture, it's a talk, okay? I'll see whether I can cover both or it may be one. I do not want to rush because the purpose is not to complete the syllabus. Usually that's what happens in case of normal lectures, because professor would like to complete his syllabus. Otherwise, the chairman of the department would say him that you couldn't complete the syllabus, right? So here the purpose is that even one slide, if I can communicate from my side to you, then this program is successful. And if I complete all my slides, and if you could not understand anything, then it's a futile exercise. You all agree with that?
Yes, sir.
Right? So purpose is that there has to be something which is being communicated, and communication means whatever I'm telling, the participants, the attendees should be able to understand exactly the way I understand it. That's what is called communication. So I would like to communicate today whatever I have brought in front of you. When I say two things I want to tell you, one is, as you can see, renewable energy, a glimpse of whatever is happening today and whatever our country has planned for future, maybe for next 5 years, 10 years, and maybe up to 2070 that we are talking. So about another 45 years. And then second thing is on hydrogen. I hope all of you know that hydrogen is being talked as fuel of future, right? And there is a lot of emphasis on hydrogen. So that's the latest thing which is happening in case of renewable. So as I said, if time permits, inshallah I'll cover both. Otherwise, let me give you a glimpse first. But the condition is that I won't be rushing. I'll try to tell you each and everything, whatever I wish to say. And in case there is any doubt, raise your hand. I'll stop there itself and I'll try to explain within the constraint of the time that I have been given. Why renewable? Why the entire globe is shifting towards renewable energy? And why not fossil fuel? So fossil fuel, as we all know, is a polluting source of energy which is creating hell of a damage to our environment. And since it is a man-made, it is we only who has created this kind of situation. So the first slide shows some of the reasons or some of the causes because of which environmental degradation is happening. Since the screen is slightly smaller, I don't know that people at the rear seat would be able to see it or not, but then I'll try. So these are the anthropogenic activities responsible for environmental degradation, right? Anthropological activities means people related, man related. So these are the man related activities. What are they? First is industrial waste that we are throwing into the rivers. If you come to Gujarat, there are so many chemical industries, or anywhere in fact. See your Yamuna itself nearer to you in Delhi, it's badly polluted because the industries are dumping their garbage and their waste into the water. So water is polluted. The forest fire is happening because of that. Third is deforestation is happening. In the name of development, we are doing deforestation, and unfortunately, the afforestation that should happen is not happening with the same speed. Usually it is said that if you cut one tree, you will have to plant 100 trees to compensate that. Now, who is doing that? So, deforestation, then soil erosion, right? Then wastewater affecting aquatic lives. Solid waste, at the bottom you can see solid waste, the plastic, millions of tons of plastics we are using and we are dumping at the dumping places or the ground, creating problem. Then desertification, again, deforestation and desertification go hand in hand. So these are reasons, right? These are causes. What is happening as a result? Drought, सूखा पड़ रहा है, right? Number two, flooding. And these are happening in a very uncontrolled way and unplanned ways. Like maybe about 50 years, 100 years back, things were happening in a very planned way. If it is hot season, it will remain hot. If it is winter, it will remain winter. And if it is a rainy season, it will remain rainy season. Not unpredictable. No intermingling of different weathers. I hope you all know that this January has been the hottest January in the history recorded. And February is also expected to be the hottest in the history of temperature records. Now, why is it happening? All the reasons are because of human activities, okay? And then one picture which is at the bottom, a cow, 52 kg of plastic has been removed from her stomach after surgery. So you can imagine. So that the situation is happening. Hence, there is a reason for all of us to be careful, to be cautious, and to do something, to think about something, right? So that's the reason that we decided that from fossil fuel, which is actually carbon emitting and polluting source, can we go to non-fossil, non-conventional, or so-called renewable sources. And renewable is something which we can renew. I mean, it's a so-called unlimited, but it's actually not unlimited, right? Even the solar rays which are coming, we all know that a day will come when sun will finally die, because millions of tons of mass is being converted into energy through Einstein equation, E is equal to mc square. Now, US Secretary General remarks in a COP. What is COP? Anybody?
Conference of Parties.
Conference of Parties. Professors are not supposed to speak, okay? You are teacher, you are professor?
No, sir, I am a research scholar.
Okay, research. Then it's okay. Okay, because the opportunity should be given to the students, okay? So, Conference of Parties, okay? So, all United Nations members are supposed to attend and give certain commitments. Recently, you must have heard when Trump came, what did he do?
Paris Climate Agreement.
The Paris Climate Agreement, from which he has disassociated, right? That's bad thing actually. Otherwise, every country gives a commitment. So what Antonio Guterres says, the United Nations Secretary General, the era of global warming has ended. We keep calling global warming, right? What does he say? The days of global warming are gone. The era of global warming has ended. What has started? The era of, loudly, global boiling has started. I mean, he is trying to shout that the entire environment is degrading, the temperature is increasing, and every 0.1 degree centigrade of increase in temperature is melting millions of tons of glaciers, because of which water level is coming up, right? So the temperature is rising. It's still possible to limit global temperature rise to 1.5 degrees centigrade. This 1.5 degrees centigrade is the commitment which was taken in one of the COPs, that in this century, entire 100 years, which started from 2000 and will end at 2099, let us say, or 100, okay? So this 100, the century in which we are living, in this 100 years, the earth temperature, the environmental temperature should be restricted, the temperature rise should be restricted to 1.5 degrees centigrade only. So he says that it is still possible to limit global temperature rise to 1.5 degrees centigrade and avoid the very worst of climate change, but only with dramatic immediate climate action. Unfortunately, he said this on 2023, and I'm here to inform you that most unfortunate part is that recently, when it was measured, we have already crossed 1.5 degrees centigrade increase in temperature. Dangerous situation. जो चीज हमें 100 साल में करनी थी, जो यूं कहो कि जो पैसे दिए गए थे कि 100 साल में खर्च करोगे तुम, हमने क्या किया? हमने 25 years में अपना बजट कंप्लीट कर दिया. This was the budget, right, of wastage, of tabahi, destruction. There is nothing but that, right? Temperature rise. This is a budget that we had taken. 1.5 degrees से ज्यादा हम अर्थ का टेम्परेचर नहीं बढ़ने देंगे. As a global citizen, we had taken that commitment, but it has already crossed. And now we are talking about 2.8 degrees centigrade, that if this speed keeps continuing, and if we do not do anything, it will go up to 2.8 degrees centigrade. And honestly, क़यामत आ जाएगी. शायद अल्लाह ताला ने एक है ना, हमें ही अपना वजह बनाएंगे क़यामत लाने के लिए. If temperature rises, the glaciers would melt and the water level of the ocean will increase. And remember, it is increasing, right? I come from Gujarat. Currently, I am staying in Gujarat. There is a place called Valsad district, right? Several villages of Valsad district is already engulfed or digested by the ocean, right? कुछ मंदिरें हुआ करती थी, कुछ घर हुआ करते थे, कुछ huts हुआ करते थे. All of those are gone into the water. So those who are residing near the seashore, they know about it, that it is happening. Okay, let's come to the present situation of our country. We are third largest energy consuming country. We are number one population, right? So third largest consumer of energy. This is an indication of your GDP, your growth, your industrial growth which is happening. GDP means gross domestic product, okay? It keeps increasing, that means you are growing. We are fourth in renewable. That's another good thing. Globally, we are number 4 as far as installed capacity of renewable energy sources are concerned. And fourth in wind and fourth in solar. So that's a good piece of news. Total installed capacity is 453 gigawatt as on October 24, but today it is 462 gigawatt. So in previous 4-5 months, we have added another 9 gigawatt. And mostly addition is renewable. So that's the good part of the entire story. So out of 453, this is the first time that we have crossed double century in terms of renewable sources. So 203 gigawatt is coming from renewable sources. And what are those renewable sources? Mainly solar. Solar contribution is 92 gigawatt, okay? Wind is 48 gigawatt. Biomass plus nuclear is 21 gigawatt. And hydro is 52 gigawatt. So all put together, we have crossed double century 200. So 203 gigawatt. So from 453, if it is 200, so almost, let us say 46-47% we are using, okay, installed capacity, remember, not in terms of number of units, because that depends upon PLF, plant load factor, or CUF, capacity utilization factor. So all of you are from electrical background?
Yes.
So hope PLF and CUF is known, okay? If not, please let me know. I'll explain that also, okay? BES, what is BESS? Anybody? Yeah, please.
Battery energy source.
Battery energy storage system. So batteries should be used for using the, for storing the energy which is being produced. Because as far as solar part is concerned, as we know, anyway, entire electricity is a real-time product. You can't store it. Either you are generating, so you need to use. So what happens if the generation is in excess? Then it should be stored. So battery energy storage. Now the problem as of today is that it is a bit expensive. Okay, but we are working to reduce the cost. And fortunately, when I'm speaking to you, the cost of storage has come down drastically. Okay, in fact, people are claiming about 1 rupee, 1.5 rupees of storage cost now. So that's affordable, no problem. Because as far as you people are concerned, you are paying about 8-9 rupees to the discoms, while the cost of electricity at which government is procuring, solar energy is being procured at what price? Anybody? Solar energy procurement cost for government? Any guess? Any guess? 5 rupees. Any other guess? Huh? Loudly. बोलो यार, गलत होगा, क्या problem है? 2 rupees. That's the right figure. Solar rate is 2 रुपया जो सरकार खरीद रही है. भले हम उसको 8 रुपए, 7 रुपए, 9 रुपए, 10 रुपए, 15 रुपए तक हम पे कर रहे हैं at certain locations, but they are procuring at 2 rupees. And BESS energy, BESS based energy, recently there was a tender which came at around 3 rupees 5 paise. So that's the reason I'm saying that it is about 1 rupee, which is the storage cost. Okay, same solar plus battery becomes energy stored through the one which is coming from renewable, right? So if solar energy is coming at 2 rupees and the combined price is coming at 3 rupees 5 paisa, so storage cost is about 1 rupee. But that's such a very large scale when you talk about 100 megawatt, 150 megawatt, 200 megawatt. At household level, it is still costing about 6 rupees, 7 rupees, 8 rupees, which is very, very high. So जितने का मुन्ना नहीं उतने का उसका खिलौना हो जाता है. So that's the reason that at house level, at home level, we are not able to use. But that promotion is happening through VGF. What is VGF?
So, viable gap funding.
Viability Gap Funding. What is that VGF? Viability Gap Funding? किसको कहते हैं? नाम तो सुन लिया, full form तो पता चल गया. What is VGF? What is the concept? Anybody? Any from student? M.Tech, B.Tech? नाम से पता चला ना? Viability Gap Funding.
Sir, through subsidy.
हाँ, yeah.
Sir, through subsidy, government is providing electricity at a cheaper cost than government and transmission cost.
But they are not calling it subsidy. Subsidy is that at your rooftop you are putting up solar power plant. It is costing you, let us say, 50 rupees per watt or 50,000 rupees per kilowatt. So you give 30,000, government gives 20,000. That's called subsidy. It's a kind of subsidy, but they are calling it VGF, Viability Gap Funding. So it is a funding to make renewable energy or battery energy storage viable. See, I'm a businessman, right? I'll put up a plant for profit purpose, right? If there is no profit, I'm not going to invest into that technology or in that product. So what government does, that if it is not viable for a businessman, so there is a gap between my viability, right? It is not viable means it is not profitable. It is a loss-making provision for me. So I would not invest any money in that. The government क्या करेगी? They will say, fine, tell me how much money I should give to you per unit so that it becomes viable for you. I'll fund it. That funding is called Viability Gap funding, okay? कि जो gap है viability में, that will come from government. Now that's again a reverse auction. One businessman says, I require 3 rupees per unit. Some other businessman who has done a better calculation, better designing, and more efficient production, he will say, I need only 2 rupees 50 paisa. Tell me, government will award the contract to whom? जो कम पैसे मांग रहा है, right? So that's called viability gap funding. समझ में आया? Hope आप लोग explain करवाओ किसी को अगर VGF कहा जाए तो viability gap funding, okay? That was the reason I told you in the beginning that there's no need to rush. You people should understand the concept because today you are in graduation, in post-graduation, or in research. Maybe tomorrow you people are going in industry. As you know, I also passed out from the same premises. This is the hall. These are the halls in which I also studied. Unfortunately, when I entered into ISRO, I found that there is a lot of viability gap. What was taught here and what I found in the real world, there was a gap. And that gap is these kind of things actually. Industry always keep doing something new. They have to grow, they have to move very fast. So that's the reason that they are always ahead. So new things keep coming. Our academia usually at least 5 to 10 years back, depending upon which kind of institution it is. Okay. So that's the reason that academia and industry interaction and trainings and meetings should always keep happening so that our product, you are the product of the institutions in which you are studying. So the product should be suitable for the market. That means you should know whatever is happening on the ground or in the field or in the industry. So these terminologies, if you know them, and when you are sitting in the interview, usually the interviewer feels that you are hands-on. You know whatever is happening on the ground. You know the industry. So you may be the right product for me. When I take interview, for example, I'm slightly going away from my talk, okay? But that's a practical tip for you. When I take interview, remember all the basic functions I have forgotten. All mathematical calculations I have forgotten. Do you think I would be remembering those double integration and triple integration and calculus, etc.? It's not possible, right? Because when you reach to that level, it's like a capsule which is being provided to you. Einstein or Lorentz might have done a lot of mathematical calculation at the back side. But finally, whatever came to the world, that was a simple equation, right? That was E is equal to mc square, which even his driver used to remember and used to deliver the lecture. तो दुनिया को आसान चीज समझ में आती है. तो जो लोग भी इंडस्ट्री में हैं, they themselves do not know those complicated calculations unless they are into R&D. Even in R&D that doesn't happen. In ISRO also it was not that complicated. They will always remain at a very superficial level. जो इंटरव्यू लेने वाला है बहुत superficial level पे होता है, बता दूं तुम लोगों को. That means if you know the fundamental things, basic things, किसी भी चैप्टर का पहला इलेक्ट्रिसिटी का फंडामेंटल चीज तुम लोगों को मालूम रहेगी, इंटरव्यू में तुम पास हो जाओगे. सेकंड थिंग जो जिसकी रिक्वायरमेंट है is that how much you know about the industry in which you are going to enter. So these are things which you must know. So maybe reading some magazines, attending some such program would always help you. So this was BSS. Coming to green hydrogen and green ammonia. That also government is promoting a lot through National Green Hydrogen Mission or National Green Ammonia Mission. Government is making so many missions. So those are missions, right? Then there is a PSP. PSP. Any idea what is PSP? Great. Pumped storage power. Okay. Being promoted through again reverse auction or through BG again. Another thing is offshore wind. आप लोगों ने onshore तो देखा होगा, है ना? जमीन पे बड़े-बड़े टरबाइन लगे हुए हैं. My company, for example, installs turbines. So there are more than 400 turbines that we have installed. They are 120 meters, they are 140 meters of hub height, and tonnage is about, let's say, 200 ton of tower and 150 ton of nacelle, and then the blades are about 70 meter in radius, so 140 meter in dia. We call it sweep dia, how much sweeping it is doing. That's a giant, right? So putting onshore, on ground is still easier. It's not easy, but as compared to offshore, onshore is still easier and cheaper, right? But then you need right place. Wind turbine कहाँ लगेगा? जहाँ हवा मिलेगी, right? So there are studies which are usually done, and then there is a minimum speed that is required. Otherwise, you would not be able to invest. So bankability report बनती है उसकी, EYR बनता है, energy yield analysis, energy yield report. So there are tools which are available. There are simulation tools which are available, in which if you feed the data, it will tell you that next 25 years, what would be the profile of energy generation. So that requires data. So mast लगाना पड़ता है पहले, 1 year का पूरा data collect करो and feed that into that with lat long, etc. Okay? Then you get the energy yield analysis, energy yield report. So people keep calling it the different names. And then bank funds it. That's why we call it bankable report. Now, offshore, समंदर के अंदर लगाना, that's very expensive. Currently, it is costing 2.5 times as compared to the cost at onshore. Who will fund it? So only government can fund it, right? So that's the reason that is being promoted through VGF again. और कितना? 8.2 crore per megawatt. That's a huge money actually. So 6,853 crore for 1,000 megawatt till 2032. And there's a feed-in tariff. FIT means feed-in tariff. Feed-in tariff is something which government decides and pays the money to you, is 4 rupees 50 paisa. 7,600 kilometers is Indian coastal line. Fortunately, we have a V kind of, our country is quite, God's given thing, that there's a V kind of geographical form. So we have the coastal area where a lot of wind farms are there, especially the western coast, West Ghat is all populated with wind farm. Fast EV penetration through capital subsidy. Then green corridor is being made. So laying of ISTS transmission line. What is ISTS? Inter-state transmission system. What is the company name? जो ISTS बनाता है, maintain करता है? Interstate, remember. Means from one state to other state, right? That's called CTU also, Central Transmission Utility. It's a utility. Power Grid Corporation of India Limited. Power Grid. I hope you all know about Power Grid, right? So that's the company which is into connecting entire India through transmission lines. Okay? Usually the voltage will be more than 220 kV, 220, 400 and 765 or even higher. So there is a green corridor which is being made, and then establishing a specific substation only for renewable. Renewable, like evacuating renewable power is a challenge for any grid as compared to thermal or as compared to nuclear or as compared to hydro. Any reason? Why is it a challenge for the grid company, transmission companies?
Intermittent nature of product.
It is intermittency. It is inform nature. कब पैदा होगा, कब नहीं होगा, अचानक कितना हो जाएगा. So grid में fluctuation is very high. It is quite unpredictable, right? It's a big challenge. When we are conducting a study, we used to find that we have predicted 100 and is coming out to be 300, right? So 300%. So that's the reason that you need to build a green corridor, which is dedicated for that, so that it is very resilient, it is very reliable, so that whatever is being injected into that, it should not collapse. Okay? So government is giving a lot of emphasis on that. Average per capita electricity production, industrially advanced nation में 14,000 है, 14,000. Like let's talk about America, Canada and Europe. What is in India? क्या लिखा है?
900.
As compared to 14,000, India is producing on requirement is 2,000 units. मेरे होटल में हमेशा जो पावर जाता है जाता है अलीगढ़ में. You are here, right? Fortunately in Gujarat, it's rare. That means there is still gap. So requirement is 2,000 units as of today. When we start developing industrially, the requirement will go up, right? So as compared to 14,000, 2,000 also is nothing, 1/7, you can imagine. So 80 gigawatt of additional thermal capacity shall have to be added to meet our demand by 2030. That's the bad news actually. Since we are growing, so we can't get rid of thermal power. It is still a necessary evil for us. We have to live with that. We know that's my killer, but still we'll have to sleep with that. So 80 gigawatt still we have to add, because after all, या तो ऐसे मरेंगे या ऐसे मरेंगे, तो अच्छा है कि खा के मरे, भूखे मरने से अच्छा खा के मरे, वाला मामला है. Now this is the goal that our country has taken. Some of you might be knowing about this. This is called Panchamrit.
Yes.
Our honorable Prime Minister is very famous in giving some names. So he gave this entire target as Panchamrit. क्या Panchamrit है? 500 gigawatt RE capacity by 2030. And what is the RE capacity that we have achieved so far? 200. So what is the gap? 300 gap. So only 40% of the target we have achieved. 60% is yet to be achieved, right? So 500 gigawatt RE capacity. Second commitment is 50% energy should come from RE by 2030. Right? That's the second commitment that we have given. Third is reduce carbon intensity by 45% again by 2030. Fourth, reduce carbon emission by 1 billion tons by 2030. So all are 2030. बाहर के जो चारों हैं, those all four targets are by 2030. We are in 2025. So another 5 years remain to meet these targets. And inshallah, the speed at which we are going, 500 gigawatt is given. We will be able to achieve it. However, others may I have doubts. So we may not be able to achieve 100%, but still we should be able to achieve a significant part of that. Now the center में जो है वो बहुत खतरनाक चीज है. What is that? Net zero carbon emission by 2070. दुनिया ने क्या टारगेट लिया है? Most of the countries that they will become net zero by 2050. That 2050 is the right year. Okay, about 135 countries have signed the declaration that we will become net zero by 2050. That means another 25 years. What is the target that we have taken? तो हमने 20 साल दुनिया से और मांगे हैं. Why? Because they all are developed countries while we are still developing, right? So when you are developing, the such needs 80 gigawatt of thermal power, as I said. So such needs will keep coming. So you require some more time in becoming carbon zero. And we have asked for another 20 years. So about 45 more years. But looking into the speed, I have my own doubt that we will be able to meet 2070 target also. It may go even higher. Recently, only about a week back, our Honorable Energy Minister gave two more statements. And that's another encouraging statement for all electrical engineer guys. Those two statements are, the power demand is going to double by 2032. अगले 7 साल में पावर की डिमांड इंडिया में डबल हो जाएगी. तो जरूरत तो पड़ेगी इलेक्ट्रिकल इंजीनियरों की. यस और नो? So you people are required, okay? नौकरी मिलेगी इंशाल्लाह. And the second is 1800 gigawatt. पहले क्या था 500 gigawatt था ना. Now he says 1800 gigawatt by 2047. हिंदुस्तान जब अपने आजादी की सेंचुरी पूरी कर रहा होगा उस वक्त तक का टारगेट लिया गया है बाय सेंट्रल गवर्नमेंट कि we'll have 1800 gigawatt. That's a massive requirement which he is talking. We all must support him actually to meet this target for our own sake. We saw where are we today? अभी तक हम कहाँ हैं? That's the figure that we saw. Okay? Boring or ठीक समझ आ रहा है? I hope. It might not be as interesting as novel or storytelling, but still I'm trying to give you some figures, some situation where we are today and where we want to be. Okay? So remember 200 gigawatt हुआ है, 300 gigawatt करना बाकी है मुझे 25 तक, तो minimum 50 gigawatt per year we'll have to do. So that's the first thing. So reverse bidding, and India is on course as far as reaching 500 gigawatt is concerned. Another thing is India is doing 57 solar parks, totaling 37 gigawatt. Okay, 30 gig. Forget about 37 gigawatt and 57 solar parks. Come to Kutch, Khavda, which is on the border of India and Pakistan. There alone, it's more than 40 gigawatt in one park. And 30 gigawatt तो अकेला अडानी कर रहा है वहां पे. I mean, that's the focus which India has given, right? So we are doing big now. 30 gigawatt offshore wind by 2030. We talked about green hydrogen and ammonia. 5 million metric ton per year. That's the target that we have taken. Green hydrogen करेंगे by 2030. Supported by that requires 125 gigawatt of RE power. Hence 20,000 crore of amount our government has allocated earmarked for that mission. And that will go to 55 million metric ton by 2050. That means hydrogen is really going to be the game changer. The smallest element on the Mendeleev periodic table. And see the capacity, okay? It's huge. 4 gigawatt of DSS, 9,400 crore earmarked for that. 20,700 crore for ISTS transmission, strengthening and making some substations. And since it's a DC power, so why to convert into AC? Can we transmit it into DC itself? So now DC transmission lines are also being established, okay? Because conversion में हमेशा energy waste होती है. So let's not convert it. 24,000 crore earmarked for PLI for high efficiency PV module manufacturing, make in India or Atmanirbhar Bharat, right? That's the first part. Second part, what is the future plan? 20,000 crore for nuclear mission. अभी ऐलान किया गया, no? सीतारामन मैडम ने ऐलान किया 20,000 crore for nuclear mission, a national nuclear mission. We'll have to go nuclear. We all know that it's slightly dicey, dangerous. In fact, Japan, for example, had to shut down its क्या नाम था, Fukushima या कुछ था ना, उसको shut down करना पड़ा था. But I mean, with a lot of control, you will be able to manage that. And recently, there is a beautiful news. I don't know whether you have heard or not. You will have a battery which can work for 50 years. No need to charge. All of you are in electrical engineering department, right? Research scholars. कैसा हो सकता है? Nuclear battery. So having atomic power. So one small सिक्के के बराबर होगा and around 300 megawatt of power. कितना? Incredible. पागल है ना जो आदमी सोच रहा होगा ये चीज को. काश के हम भी सोचते हैं इन चीजों को and हम भी करते हैं उन चीजों को. दुनिया कर रही है ना. Remember, human potential is infinite. It all depends upon how much you are using it. Please consume your brain. खर्चा तो करो उसको. हैं? पहले कहते कि सरदार जी का ब्रेन जो है वो सबसे महंगा था क्योंकि वो इस्तेमाल ही नहीं हुआ था। सरदार जी के ऊपर जोक था ना, शायद हम लोगों का भी यही हाल है कि हमारा भी दिमाग इस्तेमाल नहीं हुआ है, वी आर नॉट यूजिंग इट। We use hardly about 2.5%, 3% of our mind, and the great scientists might have used about 4%, 5%. Einstein, people like Einstein. What about remaining 95%? That's the potential that we all have. So for heaven's sake, read, think, deliberate, discuss, talk, learn. I mean, those are the only method of progress, of going ahead. Don't waste your time. I'm sorry for lecturing this ethical part also, but I consider you all bhai or bahan, hai na? Bhai or bahno. Okay? So please don't take it other way. It's a honest advice because I wasted some time here, so that's the reason I don't want you people to waste. Then promoting domestic value addition in solar PV cells, EV batteries, motors, controllers, electrolyzers, wind turbines, high voltage transmission equipment and grid scale batteries, a big boost to clean energy ecosystem. ये वो चीजें हैं जो तुम्हारे फ्यूचर के लिए हैं. When you go into the field, these are the things that you are going to work upon. So that's why I'm showing it to you. Please start googling and start getting some inputs on this. Whatever, one pager if you could write, that's sufficient for you. So let us take the most abundant thing on earth, that is water. Okay? We always say that 75% is water and only 25% is earth. So from water we will extract hydrogen, right? H2O, because it has got 2 hydrogen and 1 oxygen. So good amount of hydrogen we can get from water. And that process of extracting hydrogen from water is called electrolysis. So breaking through electricity, right? Even today, entire world is using the same electrolysis process to produce hydrogen. And hydrogen is being used abundantly in several industries. But which source of energy they are using? It's usually polluting source. Okay? And that source, if it changes, then the color of hydrogen will change. So when we talk about green hydrogen, क्या हाइड्रोजन का कलर ग्रीन हो जाता है? Answer is no. So there is a category that we have made. Okay? So it must be separated, and method of separation decides its color. So let's see what are the methods. Okay, before going to that, ज़रा मुश्किल होगा again for the backbenchers. Backbenchers are always at a disadvantage. Is it so? But truth says that backbenchers always establish an industry. और जो front runner होते हैं ना, they give service to those people. Okay, backbenchers. Because they keep using their minds somewhere else. Businessmen. See this graph. You know, मैंने कहा ना कि अंबानी ने 40 गीगावाट रिन्यूएबल का ऐलान किया है. काहे को किया उसने? कोई चैरिटी करना चाहता है? Answer is no. 41 million ton of oil, 41 million ton is being used by oil refinery out of 100. If it is 100, 41% is being used by them, oil refining. You know, there is something called sulfur. Sulfur is dangerous for oil. It's not good for oil. So they need to desulfurize it. Okay, for desulfurizing, they use hydrogen. So H2S, hydrogen sulfide. So when hydrogen goes into that, it takes all the sulfur and sulfur is removed. So desulfurization, then it becomes pure. So it is their actually need that they need hydrogen. So kitna? 41% is going to refinery. Ammonia, our agriculture, anywhere agriculture, ammonia is used as a fertilizer. So 32%, 32 million ton is going for ammonia, and 16 million ton is going for methanol, again another source of energy. 5 million ton is being used by steel and only 1 million ton by others. So pharmaceutical industries also use that. So this is the kind of breakup, and this source is from International Energy Agency. So globally this is what is happening, okay? Now let's come to the color of hydrogen. मैंने क्या कहा था कि the source of electricity or the method of separation will decide its color. Okay, what is green hydrogen that we are talking? Simple. अगर हमारा source green है, renewable energy है, RE, so be it wind or be it solar, okay?
So it will not work on screen, sir.
Sorry?
It will not work on a screen. It is for projector.
अच्छा ऐसा ही है ना, हाँ वहाँ चलेगा, यहाँ आगे ये होगा, okay. So renewable energy, right? If the source is renewable energy, it is doing electrolysis, then the produced hydrogen color will be called green hydrogen. So I have tried to make it green, और इसलिए यहाँ और बड़ा green बना दिया ताकि पता चले कि this is the source that we are talking when we say green hydrogen or green ammonia for that matter. ग्रीन अमोनिया में भी यही ग्रीन हाइड्रोजन जाएगा और नाइट्रोजन से कंबाइन होकर के अमोनिया देगा. सो प्रोसेस वुड रिमेन identical. Our company is already working on it, and maybe in another 3-4 months, inshallah, we will be coming out with green hydrogen. Second है, if you use a natural gas through pipeline or कहीं से भी, steam reforming process, and the carbon which is being generated through that, if you somehow capture that carbon and don't allow it to go into the atmosphere, then it is not polluting actually. देखने जाओ तो, if you bury it, if you store it somewhere, and if you can use that carbon in some other purpose, then it is not polluting, okay? Then it is called blue hydrogen. So next level is blue hydrogen. So you can always go for a blue hydrogen also, as compared to green. Green suppose 100% useful है, then green, blue is 95%, 90% kind of thing, okay? Now, there are other grey hydrogen. What is grey hydrogen? Same production process as blue, but you are not capturing the carbon. Carbon you are allowing to go into the atmosphere. Then it is grey. So, most of the hydrogen which is being produced today is grey. So, it's polluted. Then there is a turquoise color also. If you take methane and you burn it, pyrolysis of methane, which is split into soil carbon and hydrogen in a reactor. So, a small quantity of turquoise color also. What is yellow color? Yellow hydrogen. Same production process as green hydrogen with energy obtained solely through solar power. That means green and yellow are at the same level, okay? Because you are using only solar and then producing green hydrogen, then that color will be called yellow, सूरज से मिलता जुलता, okay? So that's okay. Green and yellow are in the same category, you can say. And then there's a pink hydrogen also. It is made through electrolysis again with power coming from nuclear energy. That's called pink. तो 7 कलर हमने देखे यहाँ पे हाइड्रोजन के. तो कभी भी नाम अगर आ जाए, you need not remember everything, but at least you should know that it is a source of electrolysis, electricity for electrolysis, which decides the color. And it could be green, blue, yellow, grey. बस ग्रे का याद रखना कि ये सबसे polluting source है. Otherwise, remaining are okay. So green, yellow and blue are still okay. Pink is also okay because nuclear is again a kind of renewable source. How green hydrogen is produced, we have already seen. I'm just repeating it for the sake of putting more deeper into your mind. This is the process of green hydrogen, okay? That renewable energy is created using solar and wind power. That power is used for electrolysis. Can you see? in this H2O, right? H2O is being broken into oxygen and hydrogen. So that power is feeding into a system known as an electrolyzer. Actually, it sounds very easy. Honestly, it's a very, very complicated. In India, unfortunately, we do not have a real electrolyzer or electrolyte producer. So we are importing from China. Okay, very cheap, very economical and very safe also. So while it sounds very simple, the concepts are always simple, remember. But its implementation might be complicated, and it is there that the role of engineers come into picture. Okay, so it is electrolysis is happening here, and then there is a hydrogen which is being generated. It is being stored as a compressed gas or a liquid. Okay, and then you can see a ship. That shows ship. Okay, ये hydrogen container में आ गया, and those containers are being stacked on a ship and being transported to the destination where it is going to be used. Okay, so this is how it happens. Same concept, थोड़ा सा यहाँ और more elaborated. This shows what are the various economies or economical activities which will flourish in case of hydrogen ecosystem. So all these areas are yours actually. You can choose any one of those areas and you will flourish in next 5, 10, 15 years. Pehla, let us say renewable. Either you need to enter into solar or wind or hybrid. So that we have already discussed, so we won't go into that. Then the electrolyzer. As I said, it is the most expensive, most complicated and rarely available in India. People are trying, but still they are importing technology from China only. So electrolyzer अगर आप बनाना शुरू कर दो इंडिया में, then you will be the king. You will become the next billionaire. So next Elon Musk is waiting in India, right? So electrolyzer. Now go up. Hydrogen storage. Okay? Because storage of hydrogen is again a very, very problematic thing. Why? It's highly inflammable as we saw. It can be stored in a compressed situation only. We'll see what is the pressure required, or liquid. Okay. So storage is another area of economic activity. Okay. Then gas power plant. You can build your own gas power plant, hydrogen based, and it goes into the electricity grid. So ऊपर वाला देख लिया हम लोगों ने. जरा middle का देखते हैं. Middle is for transportation. As we discussed, it might be produced somewhere and might be used somewhere. That means you need a transportation system. So there is a national pipeline that you can lay. The way national railways are there, roadways are there, fibers have been laid, electrical lines have been laid. Similarly, you can lay pipelines for transporting hydrogen from the place of production to destination. And same thing, from electrolysis, it can go to the hydrogen filling station. Another thing is, you can use long distance shipping. Can somebody remove this?
Yes, sir, from your laptop.
मेरे नाम होगा?
Yes.
Okay. Then industrial demand center, refineries, fertilizer makers, or steel makers. Okay. So those are industries who are going to use hydrogen. Shipping खोल सकते हो आप, shipping industry बना सकते हो hydrogen को carry करने के लिए. And hydrogen fueling substation, as I said, days are not far that you will have hydrogen fueling station at every IOC or IOL plant. हर जगह रहेगा. So this shows green hydrogen economy. Now, how does hydrogen work? So the concept of fuel cells. Okay. Again, concept is very simple. How fuel cell works? The hydrogen is entering into the fuel cell at a node. Then electron is removed. So you get H plus and electron. Electron goes up in a conductor because it needs to flow. So it's a battery, right? It becomes a kind of electricity now has started flowing. So electron has gone up, and hydrogen plus enters through. There is a small membrane. It's a very thin membrane, huh? PEM. This is called. I don't remember the PEM's full form, but PEM membrane. That's again a technology on which people are working. So it enters into the cathode area, and then there is an oxygen which is entering. So that hydrogen plus and this oxygen finally combines, and it gives out in the form of water. So water is going out here, और वहां पर एनोड में हाइड्रोजन इज गोइंग आउट, क्योंकि जो ऑक्सीजन आया था, ये जो हाइड्रोजन है फाइनली ये जो इलेक्ट्रॉन है ना जो ऊपर गया, और ये हाइड्रोजन उधर से इधर आया, तो दैट हाइड्रोजन और H plus finally meets with its separated electron and becomes hydrogen. So hydrogen outlet will be there and water outlet will be there. So two things which are going in. One is hydrogen, other is oxygen. Oxygen comes from where?
Atmosphere.
From here. It's free, right? So remember, it is only hydrogen which is entering. Honestly, okay? But there are two things which are coming out. Keep that in mind. One is water, second is hydrogen again coming out. Storage and transportation. Hydrogen can be stored physically as either a gas or as a liquid. You must have seen liquid storage रहता है ना petroleum companies का at airports, at seaports जहाँ वो आ रहे हैं या जहाँ उनका generation होता है, big cylindrical area, तो उसी तरह का रहेगा, right? So either the gas or the liquid. But the problem is in the second statement that the storage of hydrogen as a gas typically requires very high pressure tanks. कितना चाहिए? You require 350 to 700 bar. Okay, 1 bar is equal to 1 pressure. उसका यानी around कितना चाहिए? 350 to 700 time pressure चाहिए to store it. Okay, Boyle's law, PV. So tank pressure, okay, or pascals per square inch. That's per square inch. Okay. Storage of hydrogen as a liquid requires cryogenic temperature. That's the most difficult part. Okay. उसको लिक्विड में कन्वर्ट करना है तो -253 डिग्री सेंटीग्रेड ले जाना पड़ेगा टेम्परेचर. एंड व्हाट इज द एब्सोल्यूट टेम्परेचर? सो इट्स वेरी क्लोज ना. कितना है एब्सोल्यूट टेम्परेचर? आवाज नहीं आई. -273. So aren't we very close to absolute temperature? And reaching to absolute temperature is extremely difficult. Okay, there's nothing behind after that. So -253 temperature is required. ये कार का एक्चुअल हाइड्रोजन टैंक है. तो स्टोरेज के लिए यू रिक्वायर अ टैंक व्हिच इज वेरी वेरी स्ट्रांग. अदरवाइज थोड़ा सा भी लीकेज हुआ तो यहां तो सीएनजी और एलपीजी में मौत हो जा रही है. थिंक अबाउट हाइड्रोजन. ओके, इट्स हाईली कंबस्टेबल. ओके, यूज ऑफ हाइड्रोजन इन ए कार एज ए फ्यूल कैसे होता है? इस नक्शे में समझाने की कोशिश की है कि हाइड्रोजन एज वो हाइड्रोजन फिलिंग स्टेशन है, राइट? So supposing you have built the hydrogen, manufactured it, transported it to the filling substation, filling station, okay? Petroleum pump तक पहुंचा दिया उसको. So there is a pumping station. वहां से हाइड्रोजन को हमने क्या किया कि we are putting into the vehicle का जो टैंक है उसके अंदर हम लोगों ने डाला. And then from there the hydrogen is entering where? Fuel cell. इसलिए मैंने fuel cell बताया आपको. The input to a fuel cell is hydrogen. So input हुआ. That fuel cell is taking hydrogen, oxygen from atmosphere and then giving out two things. One is water, other is hydrogen. So now actually charging the battery. जो current निकलता है ना, जो current था उसका portion. That current is actually charging the battery. And that battery, finally बाकी चीज कॉमन है, power control unit and motor. Same thing is shown here. Okay. This is in 3D and this is in a kind of 2D. That hydrogen fuel is going to fuel cell, there are batteries, then control unit, and then motor, gearbox, and that's how vehicle would run. Okay. So hydrogen fueled vehicles are under pilot production, and very soon commercial version is going to come. Every company is working on hydrogen fueled car. इसी चीज को मैंने थोड़ा दिखाया है, same thing, but जो आपकी समझ में आ जाए. hydrogen car. This is the actual car. Honda City, right? यानी उसमें तो आपने स्कीमेटिक देखा ना, ब्लॉक स्कीमेटिक देखा ना आपने उसमें तो. यहाँ ये बता रहे हैं कि where exactly which component will be placed. तो हाइड्रोजन स्टोरेज टैंक इज बिहाइंड, जहां बैठोगे आप, उड़ा तो प्रॉब्लम है, हाँ सीधे अल्लाह में आ गया. So hydrogen storage tank is there. Then battery is again below that, it has to be closer to that only. Then fuel cell stack is on the co-pilot location, and thereafter PCU, power control unit, and electric motors are at their own place. So these are the exact locations where hydrogen car will be there. Current hydrogen market, anything? पूछना है किसी को? Current hydrogen market scenario. Current annual hydrogen demand is 6.7 million metric ton of India. Okay? और हमने दिखाया था आपको पहले हाइड्रोजन में कि 5 million metric ton we are planning by 2030. ठीक है ना? Because अभी हम लोग we are into the process of going for green hydrogen. Grey hydrogen is costing around 300 kg per kg, so 3 lakh per metric ton. Annual market is about 2 lakh crore grey hydrogen का. And that's the market which is available to you if you could convert it to green hydrogen. Okay? Main consumer कौन है? Refineries, petroleum plants, steel, aluminum, glass and cement industries. So these industries are under pressure for decarbonization, and that's the reason कि अंबानी साहब ने कहा है कि I will go for 40 gigawatt. They will have to switch to green hydrogen. Current price of green hydrogen is about $7 as compared to, ऊपर जो हमने देखा है 300 रुपए है, वो तो $3-4 है, और नीचे $8 है, so almost double. Okay, and we are expecting that a price point of $1 per kg. I know it's extremely difficult, but we anticipate reaching very close to about 1.5 by 2030. So that will be the day when you will be able to really use economically. World का demand है 95 million metric ton per year. By 2050 it will double, 190 हो जाएगा वो. And globally 0.5 trillion business or market opportunity by 2050. 53 billion tons of CO2 equivalent greenhouse gas emission is currently happening. Wow. You can imagine the kind of tonnage that we are putting into that mass sphere through this hydrogen process. Okay, so that we say 66% of all emissions on account of energy production, 82% of electricity from fossil fuel. This we have seen. By 2050 is expected to reverse. So another 25 years. I mean, you people will be in 40s and 50s, and 52% energy shall be produced from renewable sources in a net zero scenario, which people are talking by 2050. Okay, every 1 kg of such hydrogen produces 9 to 10 kg of carbon dioxide. So that's the challenge actually, unfortunately. Okay, I think I have already running some teachers, so I think so. That's all from my side. These are the key policies and settlement support which is coming from government. I'll leave these slides with Dr. Sheeraz Kirmani sahab, so that you can refer. These are way forward. So all again looking, what is the forward-looking statements and policies of Government of India, so that this finally takes a shape. But there are a lot of opportunities for you people in these industries. Thank you so much for patient listening. I hope it was useful for you. Thank you again and all the best.